Hello, this is Tai Fujimura. I'm the founder of Cantilever. We're a web design and development company. And today I'm going to be showing you a trick that we're using on our latest website for the Bipartisan Policy Center. And this is kind of a speed hack that we discovered. And it involves a lot of nuances as to how browsers perform when they request assets and how you can sort of manage assets within a project. So this is kind of an advanced level video just to illustrate this technique. But we wanted to get the word out about it because we were really excited about it. And we thought that more people might like to know about this kind of method. So traditionally, the optimal way to serve JavaScript on a website has been to kind of concatenate every single piece of JavaScript that you could need within the site into a main file, usually something called like app.js or scripts.js, something like that, and to serve that to the user. And the reason that that was the optimal technique for a long time was because with older browsers, parallelizing requests was very difficult. So browsers could only open either 4 or 8 requests at a time. And so you really had to be mindful that you weren't causing the browser to need to download a bunch of different scripts at once. It was much, much better to concatenate all that stuff into one request so that it could be requested and downloaded in one fell swoop. Now, with modern browsers that support HTTP2, if you have an HTTP2 compliant server, the limit is actually much, much higher. I think it's either 50 or 100 resources at once. And what that means is that for performance reasons, you're no longer constrained to having to concatenate all your resources. And that opens up a lot of possibilities for how you can optimize the performance of a site. So the concatenation strategy has 2 key flaws. The first flaw is that anytime any one of those resources changes, you have to actually update the entire bundle, and you have to deploy the whole thing, and you have to cache bust the whole thing. So anybody who comes to the site in the future gets totally fresh JavaScript, even though only 1% of your bundle might have changed. They have to download a whole new bundle, even if they come to your site all the time. And that's a performance hit. The other issue with concatenation is that on any given page, the user is only going to need a fraction of the JavaScript that you use on the site, especially if you're building a big site. So there's actually a lot of waste there because in order to render, say, your homepage, the user has to download JavaScript that's relevant to an inner page that they might never go to. And of course, since it's already downloaded, then it'll be in their cache. So when they do go to that page, it'll be faster. However, that's not a great user experience for a first-time user, especially someone on mobile, to have to download all that JavaScript ahead of time when they aren't even necessarily going to need it at some point during their journey. So because of the availability of HTTP2 and these downsides to concatenation, we've moved on to a new strategy where, first of all, we split our requests and we make a script tag for the JavaScript files that we need, and we have one file per script tag. We defer all of these resources so they don't block rendering, but they are actually split out in a way that looks totally freaky for those of us like me who learned web development in an era where this was a big, big no-no for performance. With HTTP2, it's nothing to be worried about. It performs exceptionally, and it has a couple key upsides. One of the key upsides, I'll show you an example here. This is one of the pages on the Bipartisan Policy Center site. If we look at the scripts in the footer, you can see a separate script tag for every script. And you can see a separate modified date for each of these scripts as well. And you'll notice that this is not a universal cache buster constant that's going to apply to all of these scripts. This is actually individualized for each script in the bundle. And we get this by actually reading the file modified date when we render the page, which is actually quite a bit faster than you would think. So anytime a file is edited, it's going to automatically be cache busted, and we can serve this HTML forever, along with its associated assets, and everything's always going to match up just fine. If we update the HTML, it's also going to update the modified dates to whatever the most recent change was. And so all the resources are locked in with whatever HTML the user got. So that's solving one of these problems because we're able to much more efficiently distribute these resources. But then we have the second issue, which is that traditionally, if you load all of your scripts in the footer, that means that people are going to be getting scripts that they don't need. So on this site, we've invented a methodology that allows us to avoid that problem. So I'll start by showing you one of the other pages on the site. This is the About page. The About page includes a video, And in an ideal world, what we'd be able to do is serve the video JavaScript only on the video page. And you can see if we look at the source of this page that that's exactly what we're doing. So on the About page, it has a video, and so it's loading this video.js file. Back on the Campus Free Expression page, which does not have a video, there is no video.js file. So each page is only getting the components that it needs, or 90% sure it's going to need. And the way we're doing that is by actually attaching each resource to a view. And in our system, this is a site that's built on WordPress with our custom WordPress architecture that utilizes the Twig templating language. And Twig's a fantastic system for templating. You could do this in whatever sort of templating environment you're in, and really across different stacks. I mean, there's no reason why this can't apply to a Ruby project or a Python project, let's say. But the core of it is we have a partial template called video.twig. And anytime we're invoking a video on the website, we're calling video.twig to make that. And that means that we can kind of couple the video.js script that we need to make those videos work with that code, that markup that we're delivering for the video. And what this allows us to do is make a little helper function, and in our system we're calling that require.js. And that function tells the current request, namely the controller that's powering this request, that we need the video.js file for this page. And so there's a very simplistic way to do that, which is to maintain an array of all the JavaScript that you need in a given request, and then from your template layer to just push into that array. But the trouble is you have to make sure that you don't end up with one file multiple times. So you have to customize that utility to make sure that it's doing all the right things. And in our case, we need to add that Cachebuster string as well. So that's exactly what we're doing here. Here you can see our require.js function, which is what's getting called from the Twig template. And you can see it accepts an array of scripts that should be required for the controller. And what it does is it pushes the files that were required into the controller's list of all the assets that it needs to maintain. So our controller starts out with a list of core assets that it knows it's going to need for virtually every request. And then as the views are parsed, every view is able to specify JavaScript files that it's going to need in order to function. So any given template file can actually request or require as many JavaScript files as it needs. And even if that overlaps with other files that other templates have asked for, what we're doing here is actually specifying that we only want the unique items to be added to that array. This syntax, if you're not familiar, comes from the Laravel collection class, which we're using on this project, but you could do this with any language or situation. Just check that the items are unique before you add them to that array. So that makes sure that you only end up with the things that you really, really need. And so lastly, I just want to show you one more detail of this methodology. But first, just to recap, this utility wouldn't work on its own. It needs to have a setup ahead of it where there's a queue of assets that you're going to inject into the page. And then you're going to need to have a block in your footer or wherever you're outputting your scripts that can process this array. But we really like the strategy because usually in our projects, markup is pretty tied with the JavaScript that is going to operate on it. And there's a pretty good solid one-to-one connection there. So it makes a lot of sense to have a template file and then to specify a particular script that you need for that template file to really work. One key downside to this that I want to note is that if you wanted to have a figure class video that functioned the same way somewhere else, you kind of have to use the partial template now. You don't really have the option of just copying this HTML and modifying it and putting it in a different place without copying that JS require. So that's a slight downside. But in our system, we're almost always using the relevant partial to serve a certain part of the web page. So it makes sense to do this coupling. So yeah, lastly, I just want to show you the utility that we're using to do this cache busting. I haven't really seen a lot written about a technique like this. We were kind of afraid that it would be too slow, but the more we tested it, the more we found that the file mtime function in PHP is actually really fast. So what you can do is when you want to cache bust an asset, you can just, when that asset is going to be output, do a quick check on its actual file edited date using directly in the file system, and then just append that as a cache busting string onto the end of the file. So this gives you the best of both worlds where your files are updating in real time and they're getting cache busted every time they actually change, which is exactly what you want. But you don't need to use some sort of universal timestamp or deployment hash or something like that to cache bust your assets, because that might cache bust a lot of assets that you haven't actually changed. So all in all, what this gives us is that we have a unique set of assets on each page that represents exactly what the user is going to need to render that page. And what's great about this is on the first load, they're going to get these 10 or 15 scripts that most pages need, and they're going to be cache busted, and they're going to enter the cache with that timestamp. And then within that session, it's unlikely to change. So they're going to have all of these initial scripts downloaded to begin with. And anytime as they're navigating the site, they encounter a new page that has a new script that it needs based on the views that are on that page, it's just going to be able to download that one asset, and then it's going to be all set. It'll have everything else set in the cache. So we never have to download scripts that we don't need, and we never have to cache bust scripts that haven't changed. So I think this is kind of like the holy grail of asset management for our systems, and we're planning to implement it wherever we possibly can. Okay, thanks for watching. We would love to get your comments. If you notice any problems with this technique or you want to debate any of the finer points, we welcome that. And please feel free to use this methodology in your projects and let us know how it goes. Thanks.